Hello, my name is Terry Kenny, and I'm a surface water specialist with the Water Science Field Team. I'm going to demonstrate how to develop hydraulically sound shift curves for a base rating and how to apply those shift curves in time hydrologically. This demonstration is going to be slightly different than some of the previous ones you've seen in this series. We're going to be using GRSAT, and we're going to be acting as though we are working record up operationally in a continuous fashion. I've already opened up GRSAT and loaded the shift demo XML file. You can see we have a multiple offset rating. Comprised of 3 straight line segments connected by smooth transitions at the breakpoints. We have a breakpoint at 11.4 feet of stage and a second breakpoint at 36.1 feet of stage. As I indicated just a minute ago, we are going to be working on shift curves in an operational sense, very similar to continuous record processing. And so with that in mind, we are going to turn off all measurements except for the very first one, measurement 665. So you see they're grayed out, and I'm going to toggle off the show hide unselected measurements, and they're gone now. So we're going to pretend that we are getting these measurements sequentially post field trip and developing hydraulically sound shift curves and then applying them hydrologically in time, and then we'll move on to the next measurement as if we just collected some new data and we have hydrographs to look at and that sort of thing. We have measurement 665 made on October 16th that we need to see whether we need to apply or develop a shift curve for. So let's go into the variable shift diagram and zoom in to that measurement. And as we can see, the error bars of that measurement do not overlap with the rating curve as represented by the 0 line. Now we have a previous shift curve brought into this record working period that starts on October 9th, and it has already defined some sort of a shift curve strategy with a hinge point shown here at 10.7 feet of stage and a merge point at 11.4 feet of stage, which you can see conveniently corresponds to the break point, that location in which we are identifying a change in offset and therefore a change in control segments. So what's obviously happened is someone has developed a strategy of having some sort of a hinge point at this gauge height and obviously the merge point at this gauge height. What we recommend folks to do is select a hinge point, that gauge height in which the shift curve begins to work its way towards the rating curve, to be somewhere high up in the area of the rating curve segment, somewhere up in here, to which for most shifts that you'd expect would be a smooth transition into the merge point at 11.4 feet for this example. So what we need to do is define a hydraulically sound shift curve. Because someone's developed this strategy, brought it into this record working period, we are just going to clone this existing shift curve. And of course I want to do that. I say yes. By default, GRSAT will assign a start date of 1 day past the shift curve that you are cloning. While I don't know exactly when I want to apply this shift curve that I'm developing, for the sake of starting out and defining the shape of the shift curve, I typically begin it with a start date of the measurement time. So measurement 665 was made on October 16th, so I'm going to adjust this to October 16th. At 12:45, type that all in, and then I can add a remark, and I'm going to put something very simple, not too descriptive, but it's for measurement 665. We would like to see more descriptive remarks, something more specific to the control and what's going on. If it was something related to scour or to fill, it'd be nice to put that in the remarks section. I'm also going to change this color because the background of my graph here is green. So I'm going to make this one blue just for the sake of simplicity and for viewing it. So I'm going to hit apply. And now I have a new shift curve, which is exactly the same as the previous one. So I have these inputted gauge heights already set up for me. I'd probably like to adjust them to get the shift curve to go through this measurement as best as I can. So I'm going to zoom in here just to make things easier to see. And you can see that a shift of about minus 0.05 is probably going to be about what I want to apply for this measurement. So I have these input points already set for me. I'm happy with them, I think. And I can just toggle these radio buttons to go up by whatever the step increment is here. I typically want to set the step here to be 1/100th of a foot. So I'm going to change that. And then I'm going to move these over, at least the first one, until it gets to about where I want it to be. And I said 0.05 minus 0.05 is probably where I want to be. And then I'm going to do the same thing for the second input point, which represents the hinge point, that gauge height where the shift curve begins to transition back to the rating at the merge point right up here. And then obviously my merge point, 11.4, is going to be 0. That's where the shift becomes the rating. And then for all stages above that, we are on the rating as well. So the shift curve looks pretty good. I mean, I think it looks good on the variable shift diagram. We've shared the same input points, but what's really important is not that it looks good on the variable shift diagram, is that it looks good on the rating curve itself, particularly that the slope of the shift curve, which becomes the shifted rating at the time of application, mimics the base rating form, has a very similar slope. It's a very smooth transition back into the rating and that sort of thing. So I'm going to zoom into the segment here that I'm interested in, the section control segment, and I can see my shift curves as blue line, and it's smoothly going to 0 at this breakpoint of 11.4 feet. Again, I could zoom in a little bit closer just to make sure nothing is drastically changing. And from what I can tell here, it's not. And I would expect that after looking at what my selected input points were in the variable shift diagram and that sort of thing. Our shift curve is hydraulically sound. That is, it mimics the base rating, stays true to the control that is being affected by whatever's causing the shift. And now it's time to define how we want to apply this shift curve in time. And that would be how would be done by looking at the hydrograph and thinking about the hydrologic application of the shift curve. So GRSAT has the time series view down here where the last processed and computed unit value discharges are made available when you pull them out of the database, and you can see the hydrograph here. Now remember, we are working on this operationally. Let's pretend we don't see any of the hydrograph past this measurement because we wouldn't have that kind of information available to us. So we'll zoom into this time period just slightly past the measurement. And so this is typically what you would be dealing with in an operational sense. So what we can see here is we have a small little event that happens, and then we have a measurement that's made at the recession or very near the bottom of the recession itself. And coming into this record working period, someone has decided to input a 0 shift at the peak of this event. So we can go with that information, and then seeing that our shift associated with measurement 665 is some sort of a fill shift, right? It's a negative shift, that we probably have some filling that happened on the control during the recession of the event. And so applying the measure or the shift associated with measurement 665, we'd want to apply it at the end of the recession, essentially, right? We have an amount of material that has filled in on the control as energy dropped during the hydrograph recession, and we go from there. And if you look at this measurement itself, it's made pretty much at the bottom of the recession. So for this instance, it makes sense to probably start or input this shift on the start time or end time of the measurement 665. And we've already done that, right? We cloned the shift, the previous shift, and then we put a start date of the measurement itself. Now I want to show you some functionality associated with GRSAT in the time series window and dealing with shifts and the application of shifts in time. Looking at the shift bar down here, right, this middle section of with these orange boxes, essentially, we have an orange colored box here with a line beginning at the start time of the previous shift. This shift applied on October 9th corresponds to this line right here. This is the start time of that shift. And similarly, the line shown right below measurement 665 is the start time we assigned to that shift. Now, it's important to understand there's two different colors of boxes that correspond to how shifts are behaving between one another. And these two obviously are the same color orange, indicate that the two shifts are prorating into each other. And so this start date, this shift that's inputted here, is input at this point in time, and then it prorates across till it gets to this other line. And then similarly, this inputted value prorates to whatever gets input later on. Now, I said there's two different colors. When you put an end date on a shift, you get a different color orange down here. And let me show you by putting an end date on this first shift. So I'm going to highlight this shift. I'm going to double click it, and I'm going to just arbitrarily put an end date of let's go 10/15/2008, hit apply. And you'll notice that the rectangle here became a different color orange. And you will also notice that there's a gap or a white space between this end date and this start date. And that is to illustrate the fact that when you put an end date on a shift, what you're doing is whatever the value you inputted for the shift on this date is the same all the way across this box and goes to this end date. And then after that end date, no proration's happening to the next start date. Essentially, it's a null shift. It's a zero shift value going on here. And so you have to keep that in mind if you're going to be ending a shift and then starting one at right after that end time. You could potentially have a jump in unit values because there's no proration happening. So keep in mind that what end dates do and what they mean. And what's nice about GRSAT is you have a different color box down here in the shift time series to see what's going on. Something else that's nice to know or nice to be able to do inside GRSAT is the ability to adjust these dates graphically. So I could click on this adjust date button here, and I could click on this shift curve associated with the start date of 10/9/2008, and I can grab it and move the start date anywhere I want. See that? And it gives you the times. Pretty nice. And I think we had it starting on 10/9 at 0. I can adjust it here if I didn't like the way it worked. Hit apply. And then I can grab this end date, so I can adjust the end date. So if you look here, the end date pops up here, right? And I can move it back and forth to wherever I want to go. I can slide it right up against the start date of the next one, but keep in mind, because there's a different color orange here, there's no proration happening. So let's go back and let's remove this end date because I don't want to put an end date on here. I have something happening hydrologically that I'm going to blame this shift on, some sort of a fill during the recession. So I'm going to turn off the end date. It's gone. Hit apply, and the color goes back to where it was. And so when you see this color, remember, whatever the inputted shift value is, the front end of this box prorates into the front or to the shift value that's input on this next box over here. So getting back to our example, because this measurement was made essentially at the bottom of the recession, I think I'm happy with starting the new shift curve on that measurement. Some other neat little tool that GRSAT has, you can see how things are prorating from one shift curve to the next shift curve. If you click on this little time slider clock right here, you have the ability to move this line on the time series, which corresponds to being able to view what the shift curve is or the shifted rating is at that point in time. So as you can see, I have a zero shift that I've input right here on October 9th. The purple line is on the 0, just like what was input. And I can see over time how that 0 shift curve is prorating out towards this minus 0.06 shift curve that I've defined. So I can see how the application of my shifts and how things are prorating, if it's agreeing with how I'm thinking the event or the cause for the different shifts is happening. So I can always use this to make sure that my shift curves look good on the variable shift diagram. I can look and see how they are plotting on the rating as well. So I can zoom into the rating, and I should be able to see that same purple line in here, although everything's really close. You can see that there's the blue line and then there's a purple line in here that does change as I adjust that time slider. You can see it's closer to the rating than the red line there. So I'm going to turn off that time slider by clicking on it, and we are ready to move on to our next measurement. So let's zoom everything out, get rid of our zooms, auto scale everything, and add our next measurement that we collected. So now we have measurement 666 made on November 20th. And what we can see is it was made at a gauge height slightly lower than our last measurement, and it plots in a fairly similar fashion at a minus 0.04 shift. Now what we can see is the error bars from measurement 666 do cross over the shift curve that was defined by measurement 665 and applied at the time of measurement 665. So we could just leave that shift curve active. Because remember, when we have error bars, we are assuming that the measurement is anywhere in between those error bars. But for the sake of illustration, I'm going to develop another shift curve just to show you how it's done and talk about how things are applied in time. The thing about working up records continuously is you don't have hindsight. You don't have the ability to draw a single shift curve that splits multiple measurements because they're all plotting kind of in a similar fashion. And typically you're going to have to develop shift curves from one measurement to another measurement and then look at the hydrograph and apply them in whatever fashion you need to. So again, I'm going to take advantage of the cloning. Remember, we have a nice strategy set up here. And when we have multiple shift curves for the same control, we want to share those hinge points and merge points so that we have smooth transition and we don't have shift curves crossing one another. That'd be like having ratings crossing one another. So it makes for a nice smooth way of prorating from one shift curve to the next shift curve. I'm going to highlight that measurement made on October 16th. I'm going to hit the clone tool, and of course I want to clone it. And remember, it's going to just by default assign a date of 1 day later than the shift that was cloned. Again, we're not looking at the hydrograph yet. We're just getting started on developing the shape of the curve. And for that matter, I'm just going to assign the same date as the measurement when it was made. So 11/20, I can use these radio buttons, bump it up. At 12:35, and then of course when you clone a shift, you're going to get the exact same remarks from the previous one. So keep that in mind. I'm going to change this to my real simplistic remark. Again, I would like to see more when you are working stuff operationally, give some cause and effect in the remarks. Color's orange, which is going to work out just fine. And I'm going to hit apply. And you can see looking at the variable shift diagram, it's the exact same shift as the previous one. It's highlighted, so now it's orange, but if I clicked on the other one, it would be blue, but it's the exact same shift curve. And once again, we have already defined hinge and merge points, and it's just a matter of adjusting the amount of shift value for the next measurement. Now I can use these radio buttons that I used before, but I also have some graphical tools down in the variable shift diagram that are really useful as well. I have the ability to click on this button that moves the shift point. Now that means I can grab the shift point and move it anywhere, up, down, side to side. Now because I already have some established inputted gauge heights, I don't want to do that because I would have to fine tune the gauge height value as well as the inputted shift value. Now I have these other two tools to the right of the move shift point. One that moves the shift curve only horizontally. You can't move it vertically, which is what I probably want to do here because I don't want to move the shift point beyond or different from the inputted gauge heights. And then likewise, I have one that I can just move it vertically. And that's not what I want to use here because I want to adjust the shift amount. That would be the way to adjust the inputted gauge height. So I'm going to click on the move horizontally button, and I can grab any one of these shift points. I'm going to grab the bottom one first. I'm going to slide it over to this minus 0.04 feet. I'm going to grab the other one and move it over. And you'll notice if I go up and down, it doesn't move at all. And so what I've done is I've maintained the same inputted gauge heights and just adjusted the shift value. And once again, I want to have the same merge right here. Now I can show the previous shift curve or any other shift curve on the variable shift diagram just by clicking on the box, and it will show up as a dashed line corresponding to the same color that's shown on the number right there. And so I could highlight this one, it'll be solid. I could highlight the lower one, it would be a dashed orange line. Pretty handy stuff. Once again, I believe I've developed a hydraulically sound shift curve by sharing the same input points. And it looks good on the variable shift diagram, but it's always important to look and see how that shift curve looks on the rating curve itself. And same as I saw before, the lines look really similar. The slope is very similar to the base rating and the previous shift curve, and they're really close to each other. Hard to kind of zoom in and see major differences, but I can tell that it's merging nicely into the breakpoint at 11.4 feet. So I am happy again with the shape of the curve, the hydraulic shape of this shift curve that I've put in here. And now, once again, it's time to look into the time series view and decide how I want to apply that in time. Let's zoom in again to the area we're interested in. We only get to see so far ahead of us because we're working operationally here. And what I can see is nothing hydrologically has happened between measurement 665 and measurement 666. We have a very flat hydrograph going on here. There's really no event. There are no events to deal with or to assign any responsibility for changing the hydraulic control. And so at this point, because it's flat, I'm just going to allow that previous shift of minus 0.05 feet to prorate smoothly into a shift of minus 0.04. And I am going to start this new shift on measurement 666 because there's nothing happening in between these measurements. And so you'll see I have a start date again, once again, October 9th, October 16th, and then November 20th right here. Now, if I had wanted to, I can adjust that start date for this last shift or any of these shifts for that matter. And I didn't really show you how to do that before. So I can click on this adjust date button and I can highlight a box and I can move it in time. And because these are prorating into each other, right, there's no end dates, there's no gaps or anything. It's just defining where the proration goes from one to the other. And so I'm going to pull this back to that measurement, and I am happy with that. Let's move along and do another quick field run and get measurement number 667. So I'm going to auto scale everything, go back to where I was, unzoom stuff, and look at that. We just got back from our field run, and we obtained measurement number 667, made at a much higher stage and discharge than our previous two measurements here. So let's look at the variable shift diagram and see whether or not we need to define a shift or what kind of shift we're going to need to define for measurement 667. So I'm going to unzoom, auto scale, and I can see that measurement 667 with its error bars overlaps with the rating at this zero line. So I don't need a shift to be defined for measurement 667 other than something that's a zero. Now, when you start thinking about how these shift curves looked for the lower section control, the shift curve merged with the rating at the breakpoint of 11.4 feet, and therefore the shift above 11.4 feet was zero. And you can see that orange line right here, right on the zero line. So I could just let the shift that was applied for measurement 666 just carry forward in time. And where I'm at right now with this higher flow is right on, and the stage discharge relation is being reported properly at a zero shift. My preference at this point would be to at least define a zero shift curve for measurement 667 and then look at the hydrograph and decide whether or not I want to keep it in or figure out a way to prorate it or remove it and allow for the previous shift just to carry forward. And so I'm going to just insert a new shift curve. Keep in mind, this is at a different control segment of the rating curve, and so these inputted points, these hinge and merge point, aren't related at all to measurements made in the channel or even the overbank portions of the rating curve. So cloning this would not really save me any time. So I'm just going to insert a new shift, and it's going to ask me, and of course I do. By default, it's going to assign another date from the last one just within one day. I'm going to change this to January 1st. Or January 8th, my mistake, 2009, bump that up. I'm going to make this a different color. I'm going to make it, I don't know, let's go with this darker green. And again, this is measurement 667. And I'm going to hit apply. And because I just added a new shift curve, the inputted value defaults to a 0.1 foot a stage and a 0 shift, and the other input values aren't even highlighted because we are on the rating curve itself. Now at this point, you could just leave that because it's a 0 shift, or you could make an attempt to establish some sort of a shifting strategy for the channel control section of the rating curve. For example, if this was a site that typically has truss-shaped shifts, those kinds of shifts in which it has two merge points, one at the lower end of 0 near the bottom break point, and then out to a certain hinge point in the middle of the control section, and then merges back to 0 at the upper break point. You could kind of define that or carry that forward from previous times. For our example here, I am not going to change this. I'm just going to keep it at 0, and then, as I look at the hydrograph and decide whether I'm going to keep this shift in or not, I'm going to possibly come back and refine my input values and that sort of thing. So it's 0 right now, and let's look at the time series. We want to zoom out a bit, and then let's auto scale it so we see everything, and then zoom back in to our area of our time period of interest. Again, operationally, we're kind of don't get to see forward too much. And what we're seeing here is that we had, since the last measurement 666, the hydrograph remained fairly flat for a little while, and then we had an event that came and raised flows, and we got a measurement near the, I guess it'd be like the second peak of this event right here. And so we need to figure out how we're going to apply the shift in time. But looking back at measurement 666, we likely want to hold that shift curve steady during the flat period before the event. And so I can figure out a way to put in that minus 0.04 shift somewhere right in here. My best approach to doing that would be to clone the shift that was applied on November 20th. So I'm going to click on it, and I'm going to clone it. I want to clone it, yes. And for now, let's just arbitrarily call this December 21st. And then we can say carried shift from measurement 666 to beginning of rise in hydrograph. Maybe held's the right way, held shift from measurement 666 to beginning of rise in the hydrograph. We'll make this one, we'll make it orange as well. Hit apply. And I just arbitrarily put a date in there because I want to adjust this graphically right now. So I'm going to adjust the date of this one, and I'm going to move it to, I don't know, right about there. That looks about where the rise started. So if this was operational, if you were really working this up, you should look in at the actual computed time series of stage values and see where that exactly happened, and that's where you're going to want to hold that shift steady. So what's going on here is we had input a shift associated with measurement 666 of minus 0.04, and we cloned it and input it here as well. And so what's going on is that 0.04 shift is being held steady. It's not changing. It's prorating into itself. So it's minus 0.4 here and minus 0.4 here. And now we have a shift that was defined as a 0 shift associated with measurement 667 that we need to figure out how we're going to apply it. Shifts vary with time and with stage. We know that above a gauge height of 11.4, anytime after this measurement, we're at a 0 shift. And so everything seems to be working out just fine. So the hydrograph is above 11.4 in most cases here, and it will be rating direct or on the base rating, just as our measurement 667 had defined. So we have some choices. We can leave it as it is now, where these prorate into each other, a 0 all the way up and down the entire range of the rating curve, prorates to a minus 0.4 that starts here at the lower portion of the rating curve. But our flow is not affected when gauge height gets above 11.4 feet. So we can leave it at it as is. It seems like it makes sense. Or we could also take this shift value, this zero shift value, and stick it somewhere near the top here and just allow that lower minus 0.04 to kind of work its way out and become more of a zero shift as the flow came up. So we could do this a number of different ways. For now, I'm going to leave it as is because it works out just fine because I know what I have behind me in the hydrograph and how the shift curve is going. Whatever choice you make as far as how you're going to prorate one shift into the next shift, it needs to be documented and explained in the station analysis. So a big portion of applying shifts in time is describing the decisions that you make, why you started a shift at a certain time, why you prorated into a different shift, and that sort of thing. You need to provide that cause and effect style of narration that describes what is going on. Okay, now it's time to move on to our next measurement. Measurement 668. Just got back from the field, time to develop a shift curve and apply it in time. Looking at the variable shift diagram, we can see the measurement 668 looks like it plots off to the left and is not hitting the rating curve. So we need to develop a shift curve again for measurement number 668. Now, if you look on the overview rating plot, we can see that measurement 668 was made under section control. Of course, our note sheet, our field notes would indicate that as well. And so it's probably a good idea to develop a shift curve that has a similar form as the previous two that we made for measurement 665 and 666. So why don't we clone one of those shift curves? The one that was applied on November 20th seems like a good candidate, right? If we zoom down, we can see that it is for measurement 666. So let's clone it. And of course we want to clone it. And let's give it a start date associated with measurement 668, right? So February 28th, 2009 at, 4:26 in the morning. Yowza. It's early. And we'll just turn this to measurement 668. It's going to be blue. Let's hit apply, and it shows up down here. So let's work with it. We want to zoom in down here at the bottom. Let's get those shift amounts out towards that measurement. We're going to keep those same inputted points, the hinge point and the merge point. And we're going to hopefully see that measurement 668 fits nicely on that same sort of curve, just with a larger amount of shift. So let's bump this up to where we think we're close. Oh, minus 12 looks good there. Let's take the hinge point out there. Take it up one. Pretty close. It's nice that the gauge height of measurement 668 is below that hinge point, and it looks okay. The thing to be concerned about potentially is the fact that now this shift curve form with the common hinge and merge that we've already selected, the amount of shift is a lot more than we've seen from the previous shift curves we defined on this type of hinge and merge point. So we would want to make sure, just like the case with the other ones, that everything is smooth on the rating curve itself and how that shift curve is coming into the merge point. So let's zoom into the rating curve and look at our rating zoom 1. And it does look okay. I mean, it's certainly a larger shift down here at the bottom, but that's because measurement 668 is plotting that much further off of the rating curve. The place where we'd be most concerned, again, would be right here where the shift curve is starting to merge back into the rating curve at the merge point of 11.4 feet. And it looks good. I mean, it is out here fairly far off, but it looks like it's a smooth transition into the rating curve itself. So that looks really good. Now we need to decide how we're going to be dealing with applying this developed shift curve hydrologically. Let's look at the time series and decide how we're going to apply our newly developed shift curve. So let's grab the pan button and give ourselves a little bit more time series to view. There's measurement 668. And so what we have going on here is, remember, for measurement 667 defined a zero shift. We input a zero shift through the entire range of the rating curve at the time of measurement 667. Shortly after measurement 667, it looks like we had a fairly rapid recession, a quick drop in stream flow, and then it remained fairly steady up to measurement 668, which defined that fairly large minus 0.12 foot shift to the section control. So now we have to decide how we're going to get from this zero shift to this minus 0.12 feet of shift. And so we can look at this rapid drop in flow, right? We can make some assumptions here, possibly blame a large amount of fill on the section control to a sudden drop and loss of energy associated with this rapid recession. And then if we were to take that a little bit further, we'd want to apply or at least hold this zero shift to about the beginning of that recession. And then we would want to hold the minus 0.12 foot shift back from measurement 668 to about the point in time where the recession ended, right? And so we would blame this quick drop to be the cause of dropping material onto the section control. With that, we'd probably want to take the shift associated with measurement 667. That would be the shift on January 8th, and clone it. So we'll hit the clone. Yes, we want to clone it. And it's going to assign that next day. Let's make this the 15th just to spread it out a little bit. And we will say held shift from measurement 667 to beginning of recession. It's going to be pink, which we're fine with, and we'll say apply. Looks good. Oh, wow. That's really close to where we're probably going to carry it to. So again, you'd want to look at the unit values and decide when that recession started. Just for the sake of illustration, let's just keep that where it's at right now. I mean, we could go in here and adjust the start date for it if we wanted to, right? So let's just move it just a little bit right there. Okay, that works. So what we've got going on here is we have a zero shift here being held steady to a zero shift here. Now, I'm going to blame this rapid drop. So I would probably want to hold the shift that we defined for 668 to about this little point here, the end of the recession. So I'm going to take the shift that we defined here on February 28th. I'm going to clone that one. I would like to clone it, yes. And this one, I want to make it a little bit sooner in time, right? So I'm going to just briefly just make this 0220 just to get a starting point. And we're going to hold or held shift from measurement 668 back to end of recession. It'll be purple. That's fine. We'll say apply it. Boom. So that's this one right here, right? See, it's highlighted. And I'm going to drag this to about right where I think it goes. Again, you'd want to look at the unit values, but for the sake of illustrating here graphically, that seems like a really good place to hold it back to. So what's going on here is we have a zero shift up until the beginning of the recession. And then that zero shift quickly prorates into that minus 0.12 shift that's input at the bottom of the recession itself. And why don't we look at the time slider? So let's zoom in a little bit, click on the time slider, and see what we can see. And we can see how that purple line is working its way over to the time in which we've input it. And now it becomes that shift of minus 0.12 feet. It's time to look at our next measurement, measurement number 669. Let's turn it on. And looking at the overview, let's undo that zoom. Looking at the overview, it is a measurement that was made at a slightly lower gauge height than measurement 668. So let's look on the variable shift diagram, see what we need to do, if there's anything we need to do. And you can see that the shift curve that we developed for measurement 668 of minus 0.12 does hit the error bars for measurement 669. For this example, I am going to just let it ride and keep that shift active through measurement 669, or at least utilize the same shift curve. So I don't have to develop a new shift curve, but I'm going to clone it. Clone shift curve that was associated with the measurement made on February 28th and apply it on the start date for measurement 669. Clone it. Yep. And the date is April 27th at 13:15. A little more reasonable than 4:30 in the morning. And we're just going to change this to measurement 669. Hit apply. And you can see it's the same color, or the same location, just a new color. Let's see what kind of hydrograph happened between those measurements. So we'll pan over. Oh boy. We had quite a bit of higher flow occur between these measurements. Unfortunately, we don't have any measurements at that upper end. However, we do have some faith in the stage discharge relation at the upper end because our last higher measurement made previous to measurement 668, which was measurement 667, plotted on the rating curve. So we're not too worried about that upper end at this point changing or being unstable. At least that's what we can tell ourselves. So we will hold the same shift curve from 668 at least to 669, and we're good to go. We cloned it and we started it on 669, so we're okay there. Moving right along, let's see what measurement 670 has in store with us. So at first glance, we can see that measurement 670 was made with the under channel control conditions and at a fairly higher stage and discharge than our previous measurements. Let's look on the variable shift diagram to see what we're dealing with here. And it looks like measurement 670 plotted off the rating by about plus 0.5 feet. And the error bars are not covering not crossing over the rating 0 line shown here. So we are going to have to develop a shift for this channel control measurement. When a measurement made under channel control conditions, after you've had some lower flow measurements that plot to one side or the other of the rating curve, creates some questions and creates some potential issues that have to be resolved as more data gets collected. Now, right now, all we have is measurement 670 plotting off the rating about half of a foot. And we don't know what to expect as far as unit values of discharge or flow moving into the future. Now, we have a couple of choices to make. There are two generally accepted shift curve forms that we would likely be able to apply to this situation. The first one being a half house, which is what we've been developing for the section control shifts, where we have a merge point, a hinge point, and then from the hinge point straight down, we have a steady shift amount. Now, the other type is known as the truss shift, which I've mentioned here a little bit back and forth, in which you have the shift curve is coming off of the rating, so it starts at a 0 shift, comes out to a certain amount at the hinge point, and then merges back into the rating again at a 0 point. And typically, such types of shifts are something that can be identified with your eyes when you're in the field. A perfect example, possibly a very simple example, would be a log over the channel, right? As flow came up, the log was not affecting the stage discharge relation. And then as the water surface elevation reached the bottom of the log, you'd have the beginning of some water being backed up. And as flow got higher on the log, that amount of backwater or that effect of the log would be at a maximum until the stage got above the top of the log, and then the effect would be minimized until at some point it's completely drowned out, so you would have a truss type of a shape. Another typical visual evidence of the need for a truss shift would be if you had vegetation on the banks. And what was actually happening was vegetation was causing either a backwater, or there was less vegetation on the banks than when the rating was developed, and it would cause lower stage values for the same discharge and would have a truss shift towards the right side, which is similar to what we're seeing this measurement 670 plot as. Let me quickly show you these two different types of shift curves that we could apply or develop for measurement 670. So we're going to want to insert a shift curve below the last shift curve that's available. So I'll highlight the bottom one and then click on the insert below. And I do want to insert one. And let's set this for the measurement time just to get us started. May 31st. Oops. 2009 at 0900. And we'll say measurement 670. And it's black, which is fine. We'll hit apply. Okay. So let's input 3 points here. And for the top point, I know that I want this thing to merge at the top breakpoint. So I'm going to set this to 36.1 and 0. And I am going to set this for, I don't know, I'm going to just take a stab at it, make it about 28 feet. And I know it's about 0.5. And if I were to be developing a half house shift, this would also be 0.5. And you can see the type of shift curve that I'm dealing with here. Now this works really well if you don't have to deal with flow dropping below, too far below the measurement 670, and you, without any evidence of where the stage discharge relation is below here, what ends up happening is you start adding in quite a bit of discharge different from what the existing rating is. For example, we have a 1/2 foot shift occurring at the lower end, which might work. It might actually be the case. Ideally, we'd get a measurement somewhat after this high flow event to define where the stage discharge relation is after the flow came down. But unfortunately, when we're working operationally, working in continuous records, we don't have that convenience or that luxury. So we have to be careful for how long how we develop this shift curve, with the understanding that we might be overestimating, in this case, discharge. So this is what a half house type of shift would look like for this measurement made under channel control conditions. Now let's play with it a little bit and see what a truss shift would look like for this particular measurement. Again, when we were developing that half house shift, I kind of arbitrarily selected a hinge point. That's something you'd want to raise up as high as you could, again, so that most shift curves would smoothly merge with the rating at that breakpoint of 36.1. Now, when developing or determining what your hinge point is going to be for a truss type of shift, you have to think about what is causing the truss shift and come up with an idea of where about is the middle of that effect, or where that effect is the greatest. And that doesn't necessarily mean that you draw your truss shift out to the measurement gauge height. The measurement gauge height is not a hydraulic point of importance. Rather, it's something that's arbitrarily observed because you were there. So if I were to develop a truss shift for this particular measurement, first thing I would do is I would have my input point at the low end at the break point of the transition from the lower control to the higher control. So I'd set this at 11.4 feet. And because it's a truss, it would be merged, so it would be like 0 right there. And so you can kind of see what we're dealing with here. But at this point, I have not selected a good hinge point, at least not in my opinion, where it's representing the middle of where the effect of all this stuff is. And so at this point, I'd probably grab the move shift point, and I would pull this out to be somewhere in the middle of this channel control area, and whatever would be affecting the stage discharge relation in this area likely happens at a maximum somewhere in the middle of the channel control section. So if I were to draw a series of truss shifts to represent other measurements that might plot off, I would keep this same hinge point and the same merge points. I would just have a different shift amount. So I would have a truss that kind of came down to a maximum point here, and then in, and then once again down here in the middle, or down to the merge point again. Now, there are limitations to the types of shift curves that we are able to develop and apply. Keep in mind, these are very simplistic corrections to a fairly complicated problem associated with the stage discharge relation. And so there's certain rules we kind of have to follow, and we are limited by only 3 input points, right? And we want to draw shift curves that are hydraulically responsible to what we think is causing the problem, but also remain true to the base rating curve as best they can, as well as remain true to fellow shift curve forms that could be placed in there as well. So at this point, I'm going to assume that whatever happened in the field, whatever was observed in the field, indicated that a truss shift was likely to be the best approach for this measurement and the correction to the stage discharge relation for this measurement. Now it's time to take a look at the time series and decide how we want to apply this developed truss shift hydrologically. The last shift we had input for measurement 669 likely should be held to about the beginning of this increase in flow. And so what we'll want to do is we would probably want to take this shift for measurement 669, and we'll just clone it, and we'll say yes. And we're going to do this again. We're going to say held shift for measurement 669 until rise. We'll hit apply, and we'll graphically move this one to be somewhere right about there. And so the shift curve for 669 is held steady from this input point to this point here. And then we have this one for 670, which we will probably want to clone as well. And I want to clone it. And I want to start it a little bit sooner. So let's make this 5/28, May 28th. And for now, we're going to say shift for measurement 670 held back to peak. Hit apply. Now I can take the tool again and make some brash assumptions here because I don't have too much to go by, but maybe put it on the peak here. Or you could potentially put it somewhere right here, blame some of the change on the rapid rise. But what's going to actually happen when this shift curve prorates into this one is you're going to be getting a lesser shift down here and an increasing shift in time over here in the upper portion right there. And so we can zoom in and give it a look, see how things look by grabbing the time slider and putting it so we know what that shift curve looks like. And so here's where we start seeing things starting to move their way out, right? Until this point here where we think this is fully active, if that's what we think, and then it remains fully active throughout the range right here. And so if we think that's what's happening as this rise is occurring, that's when this change is happening, then we think we're applying this properly. Now, if this truss shift is related to something more stable that's not becoming more of an effect, it would probably be more responsible to apply the truss shift fairly quickly after the initial rise so that it's in full effect for the entire hydrograph here. And again, that's something that your notes are going to tell you about. It's going to be something that you will know characteristically of this site because you visit it all the time. You understand what's causing these types of shifts. But when you start dealing with shifts, the take-home message is in the channel control section of a multiple offset rating is that things get fairly complicated when you start having a change in the stage discharge relation, a temporary change in the upper channel control section. And so understand the limitations, understand how it applies. There's no silver bullet or best way to do it, but you do need to apply it so that it's at least following your reasoning and your story that you're going to tell in the narration of the station analysis. Now moving forward in time, this inputted shift on measurement 670 is going to have a zero shift, right? Because we merged with the rating at the breakpoint of 11.4 and so there's a zero shift that's going to be applied to any stage values below that breakpoint value. Just something to keep in mind, and you're going to come across this as you are inputting shifts and the future is unknown and flows are going to happen as they're going to happen. So let's move on and see what the future brings and click on measurement 671. And you can see we are now back down. Flow has come down to some degree. Let's look at our time series a little bit. And you'll see so flow has come down considerably since our last measurement, and we have a new measurement made under section control, measurement 671. And if you look on the variable shift diagram, let's zoom in down this lower portion, you'll notice that it is plotting to the right of the rating curve, something we hadn't seen earlier. But obviously this large event in which 670 was a measurement that was made and also plotted towards the right has changed something in the configuration of the section control. Now, having hindsight available to some degree, we can possibly reformulate the truss shift curve to match or to take advantage of the information we gained from having measurement 671 now. As you've noticed, as we've developed these shift curves for the different measurements made under the two different hydraulic controls that we had measurements made, we stayed true to the hydraulic control, and that is our shift curves were only active throughout the region specific to that control. For example, if you look at our section control shifts, the ones we made for measurement 665, 666, 668, and 669, we drew shift curves that merge back to the rating at the breakpoint, the transition zone between the two controls. And similarly, when we developed this truss shift for measurement 670, we made some assumptions that this was specific to only the channel control and was not having an effect on the section control. And this is the general mindset or the general operating procedures we'd like to see everybody using, in which the understanding is as flows come up, the effects to one control are drowned out and they're not noticed on the next control that's higher up. Cases in which you're coming off of a shift made to, say, the channel control, coming down into the section control, are one of the few instances where it's almost okay to combine the shifts to some degree because of the limitations we have in applying 3-point shifts and remaining true to the control conditions. And so when I was saying we might be able to refine or improve the developed truss shift, it's possible here that we could take the truss shift that we initially had and come down off of it and then come down through measurement 671. So I'll show you what I'm talking about here. I want to clone this last shift, so I'll clone it. Yep, I want to clone it. And for the time being, I will start again on the measurement. So measurement 671 was made in August. Oops. 10th. And we'll say this is for measurement 671. And well, let's put a time in there, my bad. 5:30 a.m. Holy cow. Okay, and we will apply. And now let's do what I was saying. So if I zoom in, I'm going to keep the hinge point that existed, and I'm basically just going to be adjusting this merge point. And so I like that it's at the transition zone between the controls, right, at 11.4. So I just want to move this horizontally. I want to move it out just a little bit, like so. And now you'll see when I zoom out that I've got a truss shift that kind of merges into what would have been a half house for that lower section control. Now we are violating that rule of thumb that we want to keep or compartmentalize shift curves specific to their control, but this is one of those examples where it's difficult to draw shift curves that are allowed to cross through that transition zone right here. And so what we've developed is essentially a compound shift, one that goes beyond one control into the other control. And so now we want to look at this time series and start thinking about how we're going to apply this developed shift curve. Now, a rule of thumb or something to think about is when you're working records up continuously and you come across an instance in which you have a shift at a location in the rating which you wouldn't expect it to be fairly unstable, like we're dealing with here in this channel control section, and you want to be able to have some flexibility to adjust the shift curves over time after that measurement. And so you might consider not finalizing record back on that measurement and give yourself a little bit of leeway to develop some or refine some shift curves if it's needed, or refine the stage discharge relation after such an event. So what we're dealing with here is, remember, we have that main, that full truss shift going into effect right here on the peak, okay? And so we can leave the one that was initially put in on that peak because the stage isn't dropping low enough between then and this little dip right here, to which we would have to deal with the lower part of that compound shift. And so we can also assume that maybe some of the extra scour that happened over here at the lower end might have happened on this rise, or you come up with some sort of a reasoning to how you want to apply those shifts. But I'd be happy keeping the full truss in here, and I would have no problem implementing the compound truss shift somewhere around over here by measurement 670. So with that reasoning, I need to adjust the truss shift that's inputted here on measurement 670. So that's the shift that started on May 31st. Yep. And so I am going to adjust this just like I did the other one, and I'm going to come down here and move it horizontally right over there. I can put this shift curve on just to look at it, make sure they're overlapping one another. It looks like I need to move this one over just a little bit further. And there we go. And now I need to adjust the start time for that refined truss shift. And remember, I decided that this quick change is going to be what I'm assuming made my section control possibly move over. Again, these are things I have to come up with based on the evidence I've seen or what I know about the site. Obviously, nobody was there. There wasn't a measurement made. It's hard to know exactly what happened. But that's the reasoning I'm going to give. So I'm going to move this start time over to here. And I would like to adjust the remark for this one. And so refined truss, or actually compound truss, developed using measurement 670 and 671, held back to rapid rise during high flow event. Hit apply. It's just good to keep those notes going. Moving forward, I've got another measurement, 672, to see where it plots. And it looks like it's made during this lower flow period following measurement 671. And let's look on the variable shift diagram, which is getting a little bit busy. Let's turn off some of these older shifts that I kept on a little while ago and deal with the current one that we're looking at. And it looks like measurement 672 plots almost exactly the same place as measurement 671. So this is a pretty simple solution here. Let's just clone that last shift curve associated with measurement 671 and give it a start date of September 9th, 2009 at 10:44. And we'll call this measurement 672. Hit apply. Now we basically have the same shift curve entered right here, and right here. So it's the same. Nothing is prorating over time during this event. Everything is staying the same during this low period and coming off of this recession. Now, it looks like I've got a higher flow event coming up soon after measurement 672. Instead of just keeping this on the start time of the measurement, I'm going to adjust the start time back just a little bit to the beginning of this event, thinking that I know for sure that I can go that far ahead in time before I load up my next measurement. So let's load up our next measurement, 673, see where it plots. And it's another high flow measurement made under channel control, very close to the transition to the overbank, slightly lower than that measurement 677. And if you look in the variable shift diagram, measurement 673 is crossing the rating, the base stage discharge rating. And so we could just zero out our shift curve or apply a zero shift curve at this stage. And so let's move the time series over just to look at it before we develop the shift curve. And it looks like we have an event that comes up, typical of all the events of this site, that remain high for quite some time before dropping down. So I would be inclined at this point to develop a shift curve of a 0 for this upper event. However, understanding that I don't know what's going to happen at the lower end after this event recedes, right? I don't have the time series in front of me. If I was working this operationally, I would not know what the future held. But I am going to develop a shift curve. I'm just going to insert one at the very bottom of my list here. I do, and I want it to start on this measurement, 1020, 2009 at 1212. Measurement 673. And hit apply. And as you can see in the variable or in the shift manager, it defaults to a 0 shift unless I want to change it. I don't think I want to change it. I'm going to keep it at 0. I'm going to assume that there's probably something's going to happen to the lower section control after this event and go from there. So what I'm going to do is I am going to adjust the start date for this measurement or for this shift to the top of the rise, basically. I'm going to assume that things changed on the rise and that everything is good. And so I go from this compound truss shift over this rise back to a 0 shift through the length of the rating. Now there's different reasoning one could apply to possibly keep the truss shift in place, right? Because the truss shift actually goes through measurement 673 as well. And one could provide some sort of an argument possibly to say that things necessarily maybe didn't change on this rise. Well, this is the type of interpretation and argument you're going to have to lay out in your station analysis. I mean, you know the site. You know how it typically shifts. You were there and saw possible differences from one visit to the next. So those are the types of things you need to keep in mind as you apply your shifts hydrologically in time. Provide some sort of an argument as to why you did it one way or another. But let's just look real quick at the time slider, how that compound truss shift is going to change into the 0 shift, right? And so we're going to see that it's slowly on this rise becoming less of an effect until finally we are on the base rating throughout the entire stage discharge relation. This demonstration stepped through a series of measurements made throughout an entire water year, but they were presented in a fashion similar to working records on a continuous basis. And you can see that there are decisions that have to be made as you develop and apply shift curves throughout a water year without knowing what the future holds as far as flows and shifts and that sort of thing. What's interesting, if you look at the shift manager, we can turn on all these shifts and we can have an idea of what kind of range in shifts we started seeing or we saw at this station throughout the entire water year. And you can look at your overview plot and you can see a series of curves happening over here. And if you zoom in on your variable shift diagram, you'll see a variety of different shifts that have shown up that you've applied throughout the year. What's worth pointing out when you look at all of the shifts over the entire year for this station is that they all remain true to the base rating curve, right? They have similar smooth slopes that merge at certain locations and gracefully come off of the rating curve and merge back in other places. We don't see any shift curves that are crossing the rating curve. We don't see any shift curves that are crossing each other. And we don't see any dramatic changes in slope in these shift curves. And that's the take-home message. We want to make sure that our shift curves, which are very simplistic when compared to the rating curve itself, remain true to that base rating. And that pretty much wraps up our demonstration on using GRSAT to develop shift curves and to apply them in time. I hope it wasn't too long and that you learned something. Thank you.